Hi, my name is John Otto. I'm the category manager here at Parts for Trucks, specializing in wheel end systems. Today we're going to speak about and talk about and discuss 8-hole and 10-hole hub piloted wheel systems, which are most common in the industry today. We need to start by determining whether you're working with a rim or a wheel. They are not the same, however very similar. This is a rim. It does support the tire, however it has an adapter ring and mounts to a spoke wheel. There are no bolt holes in it. This is a wheel. It has the portion to support the tire, and it has a disc welded in it with bolt holes in it. So your car has a wheel. It doesn't have a rim. It has bolt holes to attach it. Now, over the years, there have been two wheel systems. The first one was known as the ball seat mount, and the bolt holes were chamfered. They had a 28-degree chamfer in them, and they used a chamfered wheel nut on the front, and on the drives and on trailers on dual wheels. They used an inner nut called a thimble nut, and many people were very familiar with them, and an outer nut, and many people did not like the system. So what evolved out of Europe was known as the hub piloted system. It uses a two-piece flange nut. They swivel very nicely when they're in good shape, and the bolt holes are punched directly straight, and the wheels pilot on the hub. So what is hub pilot? Well, the wheel and the drum are both piloted on pads that are on the hub. And just a reminder here today, we are not talking anything about the bearing adjustment. We are strictly talking about mounting the wheel. So a 10-hole or an 8-hole hub pilot system is metric. It's not English thread, it's metric. It's 22 mil, 1.5 pitch. So these studs are right-hand thread versus a ball seat where there's rights and lefts. There's lefts on the left side of the vehicle, rights on the right side. These are strictly right-hand thread. They're M22 thread, 1.5 pitch. Once again, the wheel is punched straight through. You can now see the pilot pads, thus hub piloted. A ball seat mount is piloted on the studs. A hub pilot is piloted on these pilot pads that are part of the wheel hub. This is the brake drum, and the brake drum also pilots on the pads down here. So an important thing to look for when you pilot that drum on is in here on the pilot pads, and we'll get into that in further depth. But these are pads, so the wheel and the drum pilot on the pads. With regards to the tools that are necessary, it's a must that you have these. You can use different variations, but certainly you need an impact gun. It's good to have a small impact gun. The majority of the hex size on these wheel nuts, on these metric wheel nuts, is 33 mil. You're going to want some form of wire brush, wire wheel, certainly not a grinding disc. You're also going to need oil. It's the only wheel system that does require some lubrication. And of course, you need a properly calibrated and maintained torque wrench in order to torque the wheel properly to gain the proper clamping force. Thank you for joining us for this session where we discussed about the components and identification of the hub piloted wheel system and the basics of the system that you see in front of us here. Should you have any questions, please contact one of our branches or visit us at www.partsfortrucks.com. We're going to get into the nitty-gritty of inspection, which is extremely important. You have to inspect the wheel end system, going in, taking it apart, as well as putting it back together. The first thing you're going to see when you walk up to a wheel end is a tire and a wheel. You're not a tire expert, but if you see bulges, anything abnormal on the tire, cuts, stop, call a tire specialist, have them come in, and take the wheel off and remove the tire and service the tire. When you begin your inspection, you've inspected the wheel, you walk up to the wheel, you see the wheel, it's the first thing you see. And this one doesn't have the nuts attached, is to look for streaking, rust streaking around there. Specifically, you'll see it more readily on a steel wheel versus aluminum. But watch for that streaking. That streaking could be coming out of a crack, or it could be coming between the nut and the flange and the stud, and it could mean that possibly the wheel has been loose, the nut has backed off a little bit, and it has been very dry and not disassembled in a long time, so thus it's gotten rusty. You cannot see a split in the inside of the rim because it has, or the rim portion of the wheel, because it has a tire on it. But you're looking for the condition of the wheel. On a white wheel, you will often see flaking in the condition of the paint. If there's a great deal of pitting, it has to be possibly looked at taken out of service. So you've come to the wheel, you've inspected, you've looked at for cracks, you've looked for galling on an aluminum wheel or pitting on the surface of the disc. Now you have to address the studs and the nuts. The studs and the nuts are classified as hardware. The condition of the stud is extremely important. If you happen to have a stud sticking out that looks very much like this, you know you have an issue. One is broken off. If one is broken off, when you go to put it back together, you must replace one on either side. If more than one is broken, you have to replace them all. So looking for that broken wheel stud is extremely important. Looking for poor wheel nuts that are in poor condition. Either the washer is very loose, it doesn't turn smoothly, or the back surface is not flat. Those are out of service conditions. Take them out of service conditions, set them aside so that you don't try to put them back on. This is where your wire brush starts to come in handy. You're going to want to start to clean as you take it apart. You inspect as you go in, you inspect as you go out. You clean on your way in and you double check your cleaning on the way out. So you've gotten the wheel off, you've checked the nuts, and you check the studs, you've thrown out that bad nut, and then you begin to clean up again. So you haven't quite gotten down to the drum, but you're going to look at the drum as well. Not all technicians can take the drum off, but those that are, they're going to do the exact same thing. They're going to look for the disc, wear on the disc, on the crack on the disc, and they're going to look at the surface on the front and the back. For cracks, paint, there should be no paint on the back at all. And there should really be no paint on the front. Paint can cause clamp force issues, which we will discuss further. So you've gotten it apart. So now you're looking at it, and this one happens to be clean. This is brand new, so it's not rusted. But you could conceivably have a stud as you're taking it apart that looks like this. You've taken it apart, you've put the wrench on it, and it's backed off, and that's what you got. So you certainly set that aside and realize you got to change out a stud. The other ones may look good, so you take your wire brush or your drill with a wire wheel on it, but certainly not a grinder with a grinder disc. You're trying to clean things up. So you're cleaning the studs. You're cleaning these surfaces, all here. These are all surfaces that must be cleaned to put it back together in order to get the proper stack, and that's what's known as a stack, is the hub, the drum, and the wheel is known as a stack, and we need to pull that together and get it torqued properly and get the proper clamping force to keep the wheels on the vehicle. Here we have an aluminum hub that came off of a vehicle. This is why you have to inspect. You have to inspect on the way in and re-inspect on the way out. Take the out of service components out, set them aside, get the replacement components before you get ready to put it together. So what you're looking for, you've looked at the studs, you've looked at the nuts, you've separated those. You know you either may have to replace one or two, or maybe they're okay. But look in this case how bad these are. These are rusted really badly. Once we took the wire brush to them, perhaps they would clean up and be fine and work fine. But you can't tell right under there. But look at the outside of this. It's corroded. And I indicated that when that drum goes on, there can be interference here. And if this is built up with corrosion, that drum may not sit and pilot properly. And that is the key, to pilot properly. Also in here, These are the pilot pads. They don't stand out like they do here. They are machined in the barrel of this particular hub. And if they are worn, and if this pilot pad down here, this little step, is not clean, that drum's not going to seat right. The wheel's not going to seat right. You're going to have loose wheels when you torque it down. We've done our inspection on the way in. We've looked for cracks on the hub, on the face of the wheel, on the face of the drum. We've looked at the condition of the studs and the nuts, the pilot pads. We've determined that anything that should be taken out of service has been taken out of service. You have your new components, you're ready to go to reassemble. The drum is going to be the first component that goes back on. And once again, it's going to pilot. So you piloted your drum, you've cleaned your hub, so you know that drum is sitting down nice, that it's not hung up on the edge of that flange of the hub. It's not hung up in the pilot pad down in here, that step. And as you put this on, you've taken a little bit of 30 weight oil, 30 weight, and you've put a little film on a hub on the pilot, a couple drops, and then you take your finger and just give it a wipe. And we're ready to install the wheel. So you slide the wheel on. Now you're ready to begin to pull the stack together even more by starting your wheel nuts. First, with a drop or two of 30 weight oil, only 30 weight. 2 or 3 drops at the end of each stud. Don't move it around, just let it sit there, one at a time. 2 or 3 drops of 30 weight oil between the flange of the nut and the nut body. Now you're just going to begin to start to tighten them up by hand. In the next session, we're going to begin with the final stage, the torquing of the wheel to develop that stack clamping force going forward. Thank you for joining us as we discussed inspection on the way in, inspection on the way out as we reassembled, disassembled and reassembled. Should you have any questions, please reach out on www.partstrucks.com or contact one of our branches for more information. We've been discussing the hub piloted system, both the 8-hole and the 10-hole. We have a 10-hole wheel end sample here, and we're at the final stage. We've done our inspection on the way in, taken anything that should have been taken out of service, out, replaced it with new components, and we're ready to put it together. We've installed our drum, we've installed our wheel. After we've checked everything, as we've dismantled, we inspected. On the way out, we've inspected. We've replaced any necessary components. We're ready to put it together. You're going to hand tighten the nuts after you put a couple drops of oil on the tip of the stud and a couple drops of oil, 30 weight oil, between the flange and the nut body. We're going to turn them in hand tight or with a small impact gun up to about 50 foot-pounds. Then with an impact gun, we're going to take them to 50–80% of the recommended torque value, which the range is 450 to 500 foot-pounds. Each individual fleet or customer or truck driver may determine that they want to use 450, they want to set everything at 475. I know of some that want to take it right to 500. So you've taken it to 50%, between 50 and 80% of that torque value with the impact gun. You do not do the final torque with an impact gun. You do your final torque with a properly maintained and calibrated torque wrench. So we've taken it to that far. The vehicle goes out and runs 50 to 100 miles. We want to bring it back in and retorque it. Why? Because the stack could have settled. Why could it have settled? Could be debris in here, in behind the hub and the drum itself that you missed. Could be a little bit of paint buildup. Clamp force is obtained when we torque this nut down to pull this stack together. That is what holds the wheel on, and it can be affected by the settling. It can be affected by stud stretch. It can be affected by loss of tolerance in the hub. What do I mean by loss of tolerance in the hub? It really can't be measured. It's very subtle. So it is extremely important to retorque. One of the things that may happen with clamping force, which keeps the wheels on, is that the torque value may be retained, but the wheels can still come loose. That's because something is shifted back in here. That's why it's important to understand getting the clamping force right. It's clamping force. The torque is strictly the twisting of this nut around the center point of the stud. That's what torque is. Once you have everything torqued up and you've done your inspection, your retorque, one very important thing that must be looked at. Every thread of that stud and nut must be fully engaged. A half a dozen could be a dozen threads. As long as every thread of that nut is engaged, it's proper. If that stud sits inside that nut, that is not proper. There is a shallower nut available should you not be able to engage at all. And why would you not be able to engage? Perhaps you've changed the wheels. You've changed from steel wheels to aluminum wheels, which are thicker and use up more of the stud. But it is extremely important that every thread of that nut be fully engaged. Thank you for joining us in the stage where we discussed the final stage of putting the wheel end assembly back together, torquing it, retorquing it, discussing clamp force and how it is clamp force along with torque that keeps the wheel assembly together. Should you have any questions, please reach out to our branches or check us out at www.partsfortrucks.com. We're going to talk about some nuances with the hub pilot system. Every one of the systems, the spoke wheel system, the ball seat mount system, and the hub pilot all had nuances. They all wear. There is a loss of tolerances within some of the components. So it is going to happen over time. So there are some solutions that have come to development over the years. And the first one is known as the wheel check. Now this is an indicator only that the nut has moved. It will tell you if a nut has loosened. So if a nut is loosened, it's backed off, it may turn like that. That's all it will tell you, is that that nut is already loosened. This is known as a safety lock. And once again, it cannot be retorqued when it's installed. This is known as a safety lug lock. Developed in Canada, used all over the world, used by many fleets in Atlantic Canada and Ontario. It basically provides a resistance between the two nuts to prevent them from moving. It ties one nut to the other, so it is stopping the movement. They are very, very effective in preventing that nut from moving. And remember, you can retorque that nut with them on. You don't need to tie this one to this one. You can strictly tie these two. Sometimes you do see it this way. Great product. This is a thread pitch gauge. And it's designed for the M22 by 1.5 pitch thread pitch of a metric stud used on a hub piloted wheel system. And it's designed, it has little teeth. And you can set it on the stud and you can see if there's daylight, you can tell whether this stud has been stretched or not. Every time you torque a wheel, you stretch that stud. Sooner or later, as that's been on and off and torqued so many times, it can develop cracks. That's one of the reasons they crack. There's a point where it's going to break. And this can help measure it. It just sits strictly down on the teeth like that, and you can have a look. One of the other nuances with the hub pilot wheel system is the loss of tolerances in the hub. And you may get a shimmy, a vibration, and many people think it's the tire or the wheels bent. Sometimes you can take it away with a skirt nut or a sleeve nut. These are skirt nuts or sleeve nuts. This was the original one, and it's a 6 mil. It's just got a little collar. It was developed in Canada. There's a large Atlantic Canadian fleet that I believe used 3 on a wheel and took a shimmy out of the front end of most of their vehicles. What it does is the hole in the bolt hole in the wheel is slightly larger than that M22 stud. And this slides on and helps center that wheel on that stud. Now, we're saying it's a hub pilot system. It is. But as I've said, loss of tolerance, this will help clear up some of that tolerance. So that's a 6 mil. That'll just sit inside and center that one. So you 2, 4, you don't need one in every spot, but they do work. These are longer ones. This you would use with dual aluminum, and this one you could use with dual steel. or an aluminum front. So there's different lengths. The 6 mil was developed in Canada, and then the other ones were developed subsequently. There are times when you as you install the wheel and the drum, that you struggle to get the wheel centered. These are wheel centering pins, and they're threaded. They just don't slide on. There are some that slide on. These ones actually thread on the metric stud. It allows you to properly center that wheel as you slide it on. Typically you use a set of 3. You'd set them in the appropriate positions around the wheel, and you can remove them very easily. There's a hex on there, and it just helps you pilot that wheel in. You may have a dual load here. It's just another feature of help for installation going, in centering, as possibly there's a loss of tolerance. And a lot of people get concerned because there's space here, and you have to remind them that it's hub pilot system. It's piloting on those pads back inside the package. But sometimes this calms them and gives them a good idea and helps them realize the center. And then you may add a sleeve or a skirt nut opposite it as you put it together, and then you've got it centered properly. So these are available. They're available in a couple different lengths. Valuable little tool for every technician to have. I've had numerous calls over the years, but the hole in my brake drum is bigger than the stud. Well, that was because it was a hub pilot system. But it is possible that if the wheel assembly, the stack was to come loose, and you had a severe braking incident, that you could have brake shear. In other words, that this drum, the brake would grab and shear the studs. I've not heard of it, but it is a possibility. So there's some products developed, and we'll show them here. This is a drum spacer. So basically it just slides on over the stud and takes up that space here in the drum hole, in the hole of the drum, between the drum and the stud. They come in a couple different sizes. The fronts, there's a set of 6, so you put 3 on a wheel. The drives and duals, set of 10, I believe. So it's called a drum spacer. Different sizes, different thicknesses, heights this way for the different thicknesses of the disc of the drum. So that's a drum spacer. It helps center the drum. This is an internal sleeve. A portion of it centers the drum, and a portion of it centers the wheel. Handy little devices that have been developed because of the nuances in the system, because of loss of tolerance. This is a wheel guard. Wheel guards have been around for a number of years. They were first developed for the ball seat mount 10-hole hub pilot wheels. They're available for different sizes, 8-hole, 10-hole. There's even some 8-hole for smaller vehicles. This happens to be the normal one for the 10-hole hub pilot. Not quite sure what the material is, some form of plastic. It will withstand heat up to 475 degrees. Thus, you do not put it between the drum and the hub, as the brake is sitting here and creates a great deal of heat. But you do put it between the drum and the wheel. You could have dissimilar metals like the cast iron of the drum and the aluminum of the wheel. Then you'd put it between the duals if there were duals. It does work very well at preventing corrosion. It can prevent pitting of the wheel, which can affect the clamping force of the stack in putting the assembly together. So these are very important and really should be used every time, except in high heat applications such as refuse trucks, fire trucks, transit buses, a lot of stop and go, high heat situations where if they were to be used and they melt, you would lose clamping force and possibly the wheels would come loose. Thank you for joining us for this session where we discuss the nuances of the hub piloted system, the little intricacies and problems that will pop up, and the solutions that are available to correct those problems. Should you have any questions, please contact one of our branches or check us out at www.partstrucks.com.